Hey folks, in this video let's solve another problem in the algorithm series. Today let's implement binary search using a recursive approach, and the first thing I'm going to do here is include the stdio.h preprocessor directive, and I assume that everyone's familiar with binary search, and I'm not going to cover the concept behind binary search in this video, but if you have any doubts I'll link a video down in the description, and you can see that and return to this video. And let's define the binary search function first. So it takes an array as the parameter. It also takes a left and right pointers, and it takes the element x that we want to search for. And before we get into the binary search function itself, let me just tell you what's happening in the main function. In the main function, we define an array, which is a sorted array over here, as binary search can only search through a sorted array. Then we find the size of the array by finding this length of the entire array and then dividing it by the length or the number of bytes of the first element in the array. And the element that we want to find is 10. Then we are going to call the binary search function, and we are going to pass the array. The left pointer is going to be 0, that's the first element in the array. The right pointer is going to be the last element in the array, and the element we want to search for is x. And if this result returns -1, that is the element is not found in the array, then we just print that the element is not present in the array. And if it is present, we print the index where it is present, and the index is specified by the result variable. Alright, so coming back to the binary search function, this loop runs until our left pointer does not overshoot the right pointer. Our left pointer keeps moving ahead in the array, and it should not and the right pointer keeps moving backwards. And once these two pointers cross each other, so the right comes first and then the left comes, then we stop the loop and we print the result, or we return the result. And here the first condition is if we define mid value. So mid value is going to be the left pointer added with the right pointer divided by 2. So here the mid value is going to be 4. And then if the value of the array at the middle index is equal to x, then it means that our element is found, so we just return mid. And if the x value is less than the middle element, so if here 10 is greater than 4, so it's not going to run. So we are essentially going to search the if the element can be present in left subarray, because since it's already sorted, we don't need to check the other half of the array if the x value is less than the middle value. That's the whole logic of a binary search. And here we can see that our x value, which is the element that we want to find, is 10, is actually greater than the middle element, which is 4. So this recursive function is going to run, and we are essentially going to check from the index mid plus 1. So this is mid plus 1 is 10. So we are going to check from here to the end. So to the end is defined by r. So r defines where the pointer is from the end. So r defines where the pointer is from the end of the array, and our x value, which is the value which you want to find, is 10. So this function runs again, and now this function also satisfies that r is greater than or equal to l is correct. This condition satisfies. Now the mid value would be the index 2 and the index 4, and then let's add both of them. So 2 plus 4 would be 6. 6 divided by 2 would be 3. And I'm not writing l plus r divided by 2 here, because I'm specifying minus l, as there should be no overflow condition. So in case the mid value overshoots or the index or indices of the array, then it's going to be a problem for us and we have to handle that. So I'm just preventing that from happening by subtracting L from the average, from the numerator of the average over here, and that's a little modification, but the code would run without that as well. And now the mid value would be 3. As I mentioned, it's 6 plus 2 plus 4 divided by 2, which is 3. And now the array at and the element at the third index 0 1 2 3 is 10. Is this 10 equal to x? And x is 10, so 10 is equal to 10. So the middle index of the array is same as the one which you want to find. So we return the mid, which is 3 over here, and then once we return mid, the the execution comes down to this line, and result will be initialized to the value of mid, which is 3, and then result is not equal to -1, so this condition is not going to run. So it runs the second print statement and prints that the x value, which is 10, is found at the third index. So let's run the code. Yeah, so it shows that element is present at index 3. So that's all for this video, and I hope you understood the concept of recursive binary search. I'll come up with these kind of videos, I think once or twice a week, and if you have any doubts or questions, you can just leave them in the comment box and I'll reply to them as soon as possible. Thank you.